we'll discuss finding the percent composition of each elements by mass in a compound. Okay, so let's have an example. So for example, the compound is carbon dioxide. How will I be able to find the percent carbon and the percent oxygen in that compound? So what is clear is that the percentages of carbon and oxygen will result to the 100% total of the whole compound, because those are the elements that made up that carbon dioxide compound. Okay, so the first step, of course, it is necessary to list down the elements present in the compound. So if you were given the name of the substance, it is important to know how to translate in a chemical formula. Okay, so upon translating it to chemical formula, next is to find the molar mass of the compound. Okay, so the molar mass of the compound is will be carbon. So in carbon dioxide, there are 1 atom of carbon multiplied by the mass number based on the periodic table, that is 12. So the total will be 12. And oxygen. So for oxygen, the total number of atoms is 2. The mass number is 16. So that will be equal to 32. So in total, that will be 44 grams per mole. Okay, now let's find out the percentage carbon and the percentage oxygen. So when we want to identify the percentage carbon, so that will be the percentage carbon, this is percentage by mass, is equal to the number of atoms of carbon present, so in carbon dioxide. So based on the chemical formula, there are only 1 carbon multiplied by the mass number of carbon, which is 16. I am sorry, that will be 12, all over the total molar mass, which is 44. Okay, so multiply by 100. So this will be equal to 1 times 12 divided by 44. So that will be equal to 27.27%. So that is the percentage composition by mass of carbon in carbon dioxide compound. Now let's find out the oxygen. So the total number of oxygen is 2 based on the carbon dioxide chemical formula, multiplied by the mass number of oxygen, which is 16, all over 44, multiplied by 100. That will be equal to 72.72%. And when we add up this 27.27% with 72.72%, that will be almost equal to 100%. So with that, that would be the our way to check the accuracy of our answer. Okay, so let's have other example. Find the percentage composition of each element. So sodium bicarbonate, so that will be NaHCO3. Now let's find out the mass total, the molar mass of sodium bicarbonate. So NaHCNO. Na, there are 1 atom of Na. For hydrogen, there are only 1. Carbon, there are only 1. And oxygen, there are 3. The mass numbers, so multiply it with their corresponding total number of atoms. So that will be 23. 1, 12, and 16. that the total will be 84. So next step is to compute for the percentage composition of each element. So that will be percentage Na. So there are 1 atom of Na. The mass number of Na is 23. 24 multiplied by 100. So that will be 27.38%. For hydrogen, there are only 1 atom of hydrogen multiplied by the mass number, which is 1, all over 84 multiplied by 100. So that will be 1.19%. So for carbon, so there are only 1 atom of carbon. The mass number is 12, all over 84 times 100. That will be equal to 14.29%. And oxygen, so the percentage oxygen, so there are 3 atoms of oxygen based on the chemical formula, multiplied by the mass number, which is 16, all over 84 times 100. So the total will be 57.14%. So when we add up all these percentages, that will be almost equal to 100. Now let's have ammonia. Let's find the percentage composition of each elements in ammonia. So for ammonia, that will be NH3. So nitrogen, there are 1 atom of nitrogen, and hydrogen, there are 3 atoms of hydrogen, multiplied by the mass number, which is 14 and 1. This will be 14, this will be 3, all over 17. Okay, now let's find out the percentage composition of nitrogen. So for nitrogen, there are 1 atom of nitrogen multiplied by 14, all over 17 multiplied by 100. So that will be equal to 82.35%. And for hydrogen, so there are 3 atoms multiplied by 1, all over 17 multiplied by 100. So this will be 17.64%. Now let's try hydrochloric acid. So for hydrochloric acid, that will be HCl. So hydrogen, there are 1 atom, there is 1 atom multiplied by 1, which is equal to 1. For Cl, there is 1 multiplied by 35.5, which will be 35.5. The total mass number will be 36.5. Percentage composition of hydrogen, that will be equal to 1 multiplied by 1, all over 36.5 multiplied by 100. So that will be 2.74%. And for chlorine, that will be 1 atom of chlorine multiplied by 35.5, all over 36.5 multiplied by 100. That will be equal to 97.26%. Okay, let's try H2 sulfuric acid. That will be H2SO4. So H, so that will be 1. That will be 2, because there are 2 atoms of hydrogen multiplied by 1. That will be equal to 2. For sulfur, there is 1 multiplied by 32, that will be equal to 32. And oxygen, that will be 4 multiplied by 16 is equal to 64. So the total will be 98. Okay, so let's find out the percentage composition of each element. So that will be, for hydrogen, there are 2 atoms multiplied by 1 over 98 multiplied by 100. So this will be equal to 2.04%. For sulfur, this will be equal to 1 atom of sulfur multiplied by 32 all over 98 multiplied by 100. That will be equal to 32.65%. And for oxygen, so there are 4 atoms of oxygen multiplied by 16 all over 98 times 100. So that will be equal to 65.31%. Okay, so now let's have plumbic chloride. So plumbic chloride, so the chemical formula of plumbic chloride will be PbCl4. So Pb and Cl, so there are 1 atom of Pb and 4 atoms of Cl multiplied by their mass number based on the periodic table. Lead has 207.2, so this will be equal to 207.2, and chlorine has 35.5, this will be equal to 35.5. I am sorry, this will be 35.5 times 4, so that will be 142. Adding these two, this will be equal to 349.2. Now let's find out the percentage composition of lead. So this will be, there are 1 atom of lead multiplied by 207.2 all over 349.2 multiplied by 100. The answer will be 59.33%. Okay, next is chlorine. There are 4 atoms of chlorine multiplied by 35.5 all over 349.2 multiplied by 100. So this will be equal to 40.66%. Okay, so that is how we find the percentage composition of each element in a compound.